Hello, this is Ms. Russell. We're going to be learning about section 9.3 today, which is trig functions of any angle. So I would recommend you have paper, something to write with, possibly different colored pens or pencils, so you can color code your notes, a calculator, and a straight edge, depending on how neat you like to have your notes. All right, so section 9.3, trig functions of any angle. Objectives. So to be able to, 1, evaluate trig functions of any angle. 2, find and use reference angles to evaluate trig functions. So first, we're going to talk about what a reference angle is and also what standard position is. So you might want to pause the video occasionally if there's a bunch of stuff to write down. Anyway, so we're going to let theta be an angle in standard position, and the reference angle is the acute angle theta prime formed by the terminal side of theta and the x-axis. So we have to look at what all of these things mean. First of all, I just wrote here that this symbol stands for theta, and it's our angle. So theta will always be our angle. And then theta prime, you say it as theta prime, and that will always be our reference angle. Okay, standard position. So in standard position, when theta is positive, you're going to move counterclockwise, and when theta is negative, you will move clockwise. So we'll talk a little bit more about that when we get to it. I just wanted to have it down somewhere for you. All right, so standard position. If you have an angle in the coordinate plane, in standard position, you'll have your vertex of your angle at the origin. And this initial side, right, so angles are made up of two rays. One of the rays will be fixed on the positive x-axis, and that will be called your initial side. And then this angle, the one that I have drawn, opens up counterclockwise, so it's a positive theta value. And it ends at the second ray, which we'll call the terminal side. So it terminates there, it ends there. Then our reference angle is this acute angle, right, that is formed by the terminal side and the closest part of the x-axis. So in this case, it's this part of this x-axis. Okay. Reference angles, there are two things you need to specifically remember about them. So reference angles are always positive, and they're always less than 90 degrees. Remember, we said they're acute. If you get an answer for a reference angle and it's either negative or it's greater than 90 degrees, then you know that you have done something wrong. Okay, let's go to the next page. So if we're looking at reference angles, we want to look at how they change based on the quadrant that we're in. So if we're in quadrant 1, I've already drawn them in. Theta, remember, is our actual angle, and then theta prime is our reference angle. So if you're in quadrant 1, theta and theta prime are the same value. So underneath that, I would just write that theta is equal to theta prime. For quadrant 2, we have to be able to figure out what our reference angle is. So for quadrant 2, theta prime is equal to, if you go halfway around, remember that's going to be 180 degrees. So 180 minus the original angle. So 180 minus theta will give us what theta prime is. And then if we're talking about radians, we'll have that theta prime is equal to, if you go half of the way around, instead of 180, it's pi. So pi minus theta. If you look at quadrant 3, we'll have that theta prime is equal to, say this was, I don't know, 240 or something like that, right? So 240 degrees. We're not going to do 180 minus 240, right? That would give us a negative number. So we're going to do theta this time minus 180. Well, these are degrees, right? And then in radians, theta prime is equal to theta minus pi. And lastly, quadrant 4, we have that theta prime is equal to, so now we're not looking at this 180 degrees, right? We're not looking at this part of the x-axis, we're looking at this part of the x-axis. So this part of the x-axis is actually, if you go all the way around, 360 degrees. So this will be 360 minus theta. And theta prime for radians will be, if this is pi, right, and we have another half, then this will be 2 pi minus theta. You don't have to memorize these, just know that your reference angle is the angle that is an acute angle, and it's between the terminal side and the x-axis. Okay, so we're going to jump into an example. Example 3. So we're going to find the reference angle for theta prime, or the reference angle theta prime for A, theta equal to 5 pi over 3, and B, theta equal to negative 130. So we have to think about where these angles are. So 5 pi over 3, well, if we go halfway around, it's 3 pi over 3. 4 pi over 3 would be somewhere in here. So 5 pi over 3 is somewhere in here. So that's theta. And then theta prime will be here. So we're in quadrant 4. And since we're in quadrant 4, we're going to do, and we're in radians, right? Then we're going to say that theta prime is equal to 2 pi minus 5 pi over 3. Okay, well, we have a fraction, so when we are adding or subtracting with fractions, we have to find a common denominator. So the common denominator will be 3. So I'm going to put this over 1, and I'm going to multiply the top and the bottom by 3. So I have that this is equal to 3 times 2 pi, which is 6 pi, over 3 times 1 is just 3, minus 5 pi over 3. So as usual, right, when we're adding or subtracting with fractions, you keep the common denominator and add or subtract the numerator. 6 pi minus 5 pi. You treat pi like it is a variable. So 6 minus 5 is 1. So technically this would be 1 pi. but we don't write the 1 in front of variables, right? So it's just pi. So pi over 3 is my reference angle for 5 pi over 3. Okay, the next one is negative 130 degrees. So first, I want to find what is called the coterminal angle. So first, find, and we want a positive one, a positive coterminal angle. To find coterminal angles, all we have to do is add or subtract 360 degrees or 2 pi, depending on if you're working in radians or degrees. Here we're working in degrees. So negative 130, in order to get a positive coterminal angle, we have to add 360 degrees. So that's 230 degrees. So really we're going to be looking at the reference angle for 230 degrees. The only difference here, right, is that negative 130, we'd start at the positive x-axis and we would move clockwise. Here we're starting at the positive x-axis and we're moving counterclockwise. Either way, we end at the same place. So coterminal angles have the same terminal side. Okay, so we're looking for this theta prime. So we're in the third quadrant, we're working in degrees. So theta prime equals, third quadrant is theta minus 180. So 230 degrees minus 180 degrees. So our reference angle is 50 degrees. Okay, next, we're going to look at evaluating trigonometric functions. So evaluating trigonometric functions, we're going to look at the steps. So step 1 is to find the reference angle. Step 2 is to evaluate the trig function for theta prime. Step 3 is to determine the sign of the trig function value from the quadrant in which theta lies. Okay, so I want to talk to you about the different quadrants and think about where we would find positive trig functions in which quadrant. So there's an easy way for you to remember where trig functions will be positive. So in quadrant 1, 2, 3, and then 4. So all students take calculus. If there's some other way you want to remember it, that's completely fine. So we're going to look at the first letter of each word. So for quadrant 1, we're looking at A. So A stands for all trig functions. So all trig functions are positive in quadrant 1. In quadrant 2, S. So sine is positive. And not only sine, but also its reciprocal, which is cosecant. Let's put sine theta and cosecant. Oh, hold on. Cosecant theta. Okay, in quadrant 3, so t tangent theta. Why did I do this? Sorry. Sine theta is just sin when we write it like that. I don't know why I wrote the e. So tangent theta is positive in quadrant 3, and its reciprocal, which is cotangent, and cotangent theta. Quadrant 4, C, so cosine theta is positive, and its reciprocal, which is secant. The S and the C, remember, they'll be sine and cosine. We're not talking about cosecant and secant. These don't represent either of those. So this is how you know in which quadrant what trig functions will be positive. All right. Let's do an example. So we have one example left. All right, example 4. We're going to use reference angles to evaluate functions. So evaluate A, the tangent of negative 240 degrees, and B, the cosecant of 17 pi over 6. So you have to think about where these are, right? So tangent of negative 240. First, we're going to find a positive coterminal angle. So find a positive coterminal angle first. So again, if I have negative 240 degrees, I just need to add 360 degrees to get a positive coterminal angle. So that gives me 120 degrees. So 120 degrees is in quadrant 2. All right, I need to look at my reference angle. So if this is 120 degrees, then my reference angle, right, is in quadrant 2. And we said for quadrant 2, to find our reference angle, it's 180 minus theta. So theta prime equals 60 degrees. So this is 60 degrees. 60 degrees is a special angle that you learned about in one of the previous videos. So if we draw in a triangle here, right? And this is a 60-degree angle. If you think about your special right triangles, across from 60 degrees, right? We solved it for our unit circle. So across from 60 will be square root of 3 over 2. Across from 30 will be 1/2. And then our radius, right, is 1. So our hypotenuse is 1. Okay, well, I have to find tangent. And if you think about SOHCAHTOA, So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You should have learned this in geometry. I need to label my sides. So my hypotenuse is this 1. My opposite is the square root of 3 over 2, and my adjacent is 1/2. However, this is negative 1/2 because of the direction that we're going in. All right, so tangent of 60 degrees is equal to the square root of 3 over 2 over negative 1/2. Okay, I have a fraction divided by a fraction, so I'm going to keep, change, flip, or you may know this as keep dot flip, or keep the guy and multiply. So I'm going to keep the numerator, change to multiplication, and flip the denominator. Since I have a 2 in the numerator and a 2 in the denominator and I'm multiplying, I can cancel these. So I have square root of 3, well, negative square root of 3 in the top. And this just becomes a 1 if it's canceled, right? So 1 times 1 is just 1. And I don't need to write that because we don't ever write that, right? If anything's over 1, you can just get rid of the 1. So my answer would be negative square root of 3 for the tangent of 60 degrees, right? So the tangent of negative 240 degrees is also the negative square root of 3. So I'm using my reference angle to find the values of trig functions for other angles. Okay, part B. The cosecant of 17 pi over 6. So this one is positive. However, it's greater than 1 time around. So if I drew 17 pi over 6, I go past 2 pi, right? Because 2 pi would be 12 pi over 6. So I want to find, so here we're going to find a smaller positive coterminal angle. So if I want a smaller positive coterminal angle, I can say 17 pi over 6 minus 2 pi, because if I subtract 2 pi, right, I'm going all the way around once. In order to subtract these, because I have a fraction, I have to find a common denominator, which would be 6. So this becomes 17 pi over 6 minus 12 pi over 6. And again, I keep the common denominator and I subtract the numerators, and I treat pi like it's a variable. So 17 minus 12 is 5, so 5 pi over 6. 5 pi over 6 is, I don't know, about here. So I need to now find my reference angle. So this is theta, right? And then this would be theta prime. Okay, I'm in quadrant 2 again. The only difference is that I am in radians. So it will be pi minus 5 pi over 6. So this was to find my smaller coterminal angle. Now I'm trying to find what theta prime is. I need a common denominator again. Let's put this over 1. My common denominator is 6. So this becomes 6 pi over 6 minus 5 pi over 6. Keep your common denominator. Pi is treated like a variable. 6 minus 5 is just 1. We don't need to write the 1, so I'm going to write this prettier. It's just pi over 6. So that's what my reference angle is. I still need to figure out what the cosecant is. So cosecant is the reciprocal of which trig function? Sine, cosine, or tangent? It's the reciprocal of sine. Okay, so instead of opposite over hypotenuse, I would have hypotenuse over opposite. So let's draw this in. So again, I'll have 1. Pi over 6 is the same as what angle in degrees? 30 degrees. So my reference angle is actually 30 degrees, if you want to think about it like that. So again, I have a special right triangle. So I need to use my special right triangle. So opposite of 30 degrees, when you solved it with Mrs. Handy, right, was 1/2. And then opposite of 60 degrees was square root of 3 over 2. All right, so we said hypotenuse over opposite, right? So cosecant of 17 pi over 6 is equal to hypotenuse, which is 1, over the opposite, which is 1/2. So again, I'm going to keep, change, flip. So this is equal to 1 times 2 over 1, which is just 2. All right, we're all set. Thank you.